All right. Well, hi, everybody. Hello, math class. It's been so long since I've seen you, and I'm still not seeing you. Yeah, but I'm glad we're communicating again. This is great. I don't know if you saw, I had put on the Google Classroom um, a blooper of a video I just made. Actually, I had two bloopers. My first two videos were bloopers. The first blooper I couldn't put on there because I didn't record it. So I did the whole lesson, and then I clicked to end, and I clicked to record. So that happened. Then you can look at the blooper video to see what happens. Yeah, it was kind of funny. So anyway, back to math. We're going to be talking about some things in geometry this week. We're going to be talking about types of triangles. Now, triangles can be classified in two different ways. They can be classified either by the length of their sides and how many sides are equal, or they can be classified by their angles. So we're going to start by talking about classifying triangles by the lengths of their sides. So this first triangle that we're going to talk about, you know about this. This is kind of, when you think about a triangle, this is the exact triangle that you think of. The kind you learned about as a little kid is this kind of triangle. This triangle is called an equilateral triangle. Equilateral triangle. You can almost see the word equal in here. Well, it is the word equal, but it's, there would be an A here instead of the I. In an equilateral triangle, you figured it out already, I bet. All three sides are equal. The way that mathematicians show that all three sides are equal is by putting one little line on each triangle side, on each side of the triangle. Bonus points if you can figure out what that's called, that little line. I don't know what it's called. Maybe I'll have it figured out by then. But you can just let me know what that is called. But this is an equilateral triangle. I brought some fun stuff, marshmallows, keeping them in a Ziploc bag because don't you hate it when marshmallows get dried out? I do. Okay, so I've got some marshmallows. I'm going to get out 3 for the 3 vertices of a triangle. Okay, and I've got 3 toothpicks out also, of course. Now, what's great about this is each toothpick is the same exact size. So this equilateral triangle is going to be very simple to make. Each of the vertices is, actually represented by a marshmallow here. Boom, boom. Oh, it's not as easy as it looks. Oh, you said it doesn't look easy? Well, that may also be true. So here's an equilateral triangle. Simple so far. All 3 sides are equal. But let's move on. The next kind of triangle, I just put my paper on top of the equilateral, where I wrote equilateral triangle. The next kind of triangle is isosceles. We talked about this a little bit when we did our Christmas geometry picture project. Isosceles is such a weird word, and why they use it to talk about a triangle that has 2 equal sides, I don't know, but they do. But again, following the format of how mathematicians mark these triangles, here's what they do. We're going to put one line on this side. We're also going to put one line on this side because those 2 sides are equal. So one line for each means they're equal in length. This bottom side then gets 2 little lines on it to show that it's a different length. So isosceles, a good tip to remember isosceles, as Mrs. Cindy McKasick told me, who was your librarian at Donaldsville, as you remember, those many years ago. She told me way back that the way she helps kids to remember it is that you have 2 eyes, 2 crazy eyes, it looks like. Everybody has 2 eyes, and isosceles triangles have two sides that are the same. Two eyes, two sides. So that's how we know that those are, or that's how we can remember that those are isosceles triangles. I'm going to give you one more. I said I wouldn't do it. I said that to myself, not to you, but I'm doing it. The third kind of triangle is scalene. Wait. I didn't make my marshmallow thing. Okay, to make an isosceles triangle, I want to make the two sides that are equal actually 2 toothpicks each. Can you tell that I haven't practiced? I think you can. I'm pretty sure. I have practiced. I did it twice already. Something different happens every time. Okay, so I've got, first of all, my two sides that are equal to each other. And now I need one side that is different, a different length than the other two. I wish this part was on camera. Everything's falling apart. No, I was being dramatic a little bit. Let's put it over here. All right, it's a little topsy-turvy, but you can see that this isosceles triangle has two sides that are equal to each other, and then one side is a different length. There can be different looking isosceles triangles, of course. This is an isosceles triangle. Well, of course, this is the same exact triangle that I've been using. But, you know, one thing we could do to have a differently shaped isosceles triangle would be to add more toothpicks. We could make, let me finagle this a little bit. We could change this triangle so that, what has happened to this triangle? Okay, I could, whoops, the video's backwards, can you tell? I could change this triangle to where, there we go. One side, why can't I do this? One side has two toothpicks, and two of them each have one toothpick. That's another way to show an isosceles triangle, okay? So that's isosceles. There's one last kind of triangle, as I started telling you about, and it is a scalene triangle. The scalene triangle has no sides that are equal. And for some reason, I think it's the hardest triangle to draw, probably because we don't see it that often, since it's a little irregular. Oh, that was pretty good. So this scalene triangle, I don't have a way for you to remember it. Equilateral has equal, all three sides are equal. Isosceles, two eyes, two sides are equal. Scalene, you just kind of have to remember it. I like to think it's a little bit of a crazy name, and it's a little bit crazy because no sides are equal. If I start with this side and mark it with one line, that's the length of that side. This one is a different length, so I mark it with two lines. How many lines do you think I would mark this bottom one with, this bottom side? I'd have to do 3, since it's not equal to either of the others. So that is a scalene triangle. To make that with the marshmallows and toothpicks, ew, mutant marshmallow. I would eat it, but I don't like marshmallows. Okay, I lost the toothpicks. Oh, found them. Okay, so we'll take one side and we'll just make it 1 toothpick long. For your project later, you might want to do the same thing. You might want to make your triangles out of toothpicks and marshmallows if you have any. I just happen to have some left over from, the marshmallows are left over from gingerbread houses from Christmas. And the last one, I'm going to have to put out of sight here. So 1 toothpick, 2 toothpicks, and 3 toothpicks. Oh no, oh goodness. Here goes the hard part. Yeah, this is the problem. I'm gonna have to break one in half. It won't reach otherwise. Oh. Oh boy. Oh gosh. Okay. I can barely hold it up to show you. But here is a scalene triangle. It has one toothpick, two toothpicks, and then 2.5 toothpicks. I'm kind of showing you these as a model so that you can see something that you could use to make your own models of the different types of triangles.